Hi everyone, today we're gonna look at another LeetCode problem. This is 104 for maximum depth of binary tree. Given the root of a binary tree, return its maximum depth. A binary tree's maximum depth is the number of nodes along the longest path from the root node down to the farthest leaf node. Alright, let me read the problem to see if I have any questions. Let me read the problem descriptions. So we are given binary tree, the root of a binary tree, and we would like to find out the maximum depth, the depth of the binary tree. Okay, so I think that's quite straightforward. Let's try to look at the problem description. Now we got the examples here. First one is 3, 9, 20, 28, 15, and 7. So the depth here is 3, because that is the longest part there that we have. In the example 2, we have 1.22 on the right side. So the output here is 1. Let me reread the problem to see if I have any questions. So we are given a binary tree. Alright, so I think I would may I ask a few clarifying questions? May I know that the root is valid, i.e. it is a 3 node. Okay, so we are given that the number of nodes in the tree is in the range of 0 to 10 to the power of 4. Okay, so number of nodes. Number of nodes. Alright, so I think I understand the problem now. Let me think of possible approaches. I think this question is quite straightforward. What we can do is we could traverse all the child nodes from the root, and then at each traversal we could keep track of the depth, the current depth that we have explored. In the end, we are gonna return the maximum. R in a second. So I think what we can do is when we traverse, and then we keep track of what are the current depth. So for example, we traverse children nodes and track current depth 3. Okay, so what we can do is return max of the left and the right one. Okay, so at each node, the depth the maximum depth. Okay, so this would be max depth. Okay. So if there is no, so for the first one, children not. Okay, so I think that could work. Let me try to do the first example there. So the first one we have 3, and then so the depth here is 0, 1, 2. Then when we return, this would be max 2, 2. So this would be 2. And then this would be 2 as well. Okay. 1 and 2. So then we return 2. Second examples, we have 1 and then 2. At this point, we initially have 0. Actually, here we have 1, and then this would be 1. Okay, so I think that sounds reasonable. Does that sound reasonable to you? I am pretty good about this, and I would like to start coding, unless there are further optimization that you would like me to explore. Okay, so let's do this. So let's see what kind of function that we are going to implement. So given a function max depth that takes only the root. Okay, so I think what we can do is we can let's see, can we do it iteratively? I'm thinking of whether this should be done iteratively or recursively. I think recursively makes more sense in my approaches that I just described. But let's like to explore the iterative version of this. So I think what we can do is we could create a child node. So if we have a list of the child node, then we keep on iterating on that until that is empty. Okay, here's what I'm thinking. So every time I'm thinking of using 2 while loop. So the first while loop will check if there is any child node at the current level, and if so, I'm gonna iterate inside the. I'm gonna have another for loop that will go through all these nodes, and then all these nodes, and while I'm doing so, I will record all the child node of at the current level, and then by doing so, I will get the nodes at the next level until the end. I would have none no more chat node to explore, and that will be the lowest level, the leaf node, or the leaf node at the lowest level of the tree. So by doing so, so at that point I would have need a variable to record how many levels, how many depth, or how much depth I have gone into before I reach the lowest level. Okay, I think that makes sense. So what I'm gonna do is I'm gonna say current equals root, and then I'm gonna have another variable called next. So this would be just empty. Actually, let me do it this way. Current and next. The current one is empty because I haven't iterated anything. The next one will be the root. Okay, so what I'm gonna do now is that I'm gonna check. Okay, so I forgot one thing. So the depth is now 0. So while root should be while next. So as long as there is a next depth that I can explore, that I can traverse, I will do so until I don't have a next level to traverse. So at the end, I'm gonna have exhausted all the children of the current tree. Now what I'm gonna do is for node in it's a bit confusing. Okay, let me just do it the other way around. So curl and next, this would be the root, and the next would be empty. So while current or not in current, next dot append actually let me check it. If not dot left, then I'm gonna append it into our next node dot left. If node dot right, next dot append node dot right, then I'm gonna do curl next. So curl would be the next node, and then the next would be empty. In the next loop, I'm gonna iterate the next one. So let's see what I need to do now. sorry, I need to amend the examples that we go through. So it turns out that the root node is step 1. So that would be change a few things. Let me overwrite the previous examples that I have. Okay. Right. So every time we go in, we increase the depth. Then at the end, we return to depth. Alright, so let me go through the code again to make sure I don't miss anything. I will have two lists, current and next. So current, I will start. Actually, I need to check. So in each case, if the root is none, if not root, return 0. Okay, so there we have the edge case. Let me write the edge case here. So 1, 4. So the first edge case is there is only root node without any child. And then another edge case is we have a null pointer. It should be 0. There. Okay, so let me go through the code to make sure I don't miss anything. Here I'm gonna define two variables, cur and next. Cur will be initialized with the root node. Next will be empty. We could think of the next as the temporary variable that we're gonna use to store the next the nodes at the next level. Okay, so while current is not empty, we are gonna increase the depth. Then we are gonna iterate through all the child node and then add it into the next. And now at the end of the loop, we are gonna put our next children into our cur so that in the next for loop we are gonna explore the children or the children of the child, the children that we have found so far. And then so and so forth, we would have exhaust all the children until the leaf node, or and then at the end we would have the lowest level leaf node, which has no children at all. And that we would have got the maximum depth. Now let me go through the examples here. So the first examples, we start with 3. Let me write down the curve, then the curve start with 3, and then there is 1, then we will have 9 and 20, then that would be 2. After 9 and 20, we have 15 and 3, child with 3, and then we have empty. So the answer would be 3, which is correct. Second example, we have 1 and 2. So initially we have 1, then the depth would be 1, then we have 2, the depth would be 2, so the output is 2. Third example, we have curve, then depth, so curve start at 1, depth will be 1, then it will be empty. The fourth one will be just 0. Okay, let me try to think that should work. Let me try to put it into LeetCode to make sure it is expected. So next. This one. Okay, don't forget the edge case. If not true, return that. Curve initialize to root. Then next would be the empty. So while curve that plus equals 1, therefore not in curve, if not that left, next append not that left, if not that right, gonna append the chart. In the end, I'm gonna set the current to the next, and then the next will be empty again. I'm gonna return the depth and try to see if we got it right. Yep. So when you try to submit it, we got it right. And yes, we got the accepted answers. I think we don't need to look at other people's solutions, because I think it's pretty much the same thing. Yeah, so this is the cursor. Yeah, anyway, the recursive part is pretty simple as well. You could reuse the same function instead of what I said earlier. But yeah, thank you.